Okay, last time what we studied the Newton's law, and I showed you how can you use the Newton's first law, second law, and third law to solve some examples. Today we are going to continue with the same topic by solving more questions. Here, lastly, I think I solved you the example 3. Now look at the objects in equilibrium. This is this specific case, and this is related with the Newton's first law, when we said that objects that are either at rest or moving with constant velocity are called equilibrium. And so it means that acceleration object can be modeled as zero. So zero acceleration means velocity is zero, or it is moving with a constant velocity. And when you put it inside the Newton's law, you can see that F net must be equal to 0 because of the acceleration is 0. So you can write it in a vector form, but after that you want to separate it in component. If you are in the 2 dimension, the set of components are Fx net equals 0 and Fy net equals 0. This is the summation. We are going to use this sigma, capital sigma, for the summation. So it means that you want to add all forces. So it is net force. So look at here. In this example, here there is a lamp is suspended from a chain of negligible mass. The force acting on the lamp are, there are two forces. One of them is the tension force upward, and another one is gravitational force downward. And you can show them by T and Fg. And this is the free body diagram of the object. How can you transform it to the Newton's equation? If the object is in equilibrium, you can write it. Here you can see they write it, but you can write it also in unit vector notation. F net vector equals 0. So what is the upward force? Tension. So T J hat minus Fg J hat equal to 0. And after that, you can easily see that T is equal to Fg. So Fg is gravitational force, and we know that. How can you calculate it? You can calculate Fg by mg j hat. But this is downward, so minus mg j hat. Okay, this minus shows the direction, but here it is magnitude. Okay, so don't confuse. So T as a magnitude is equal to Fg. So T is equal to mg. And related to the equilibrium, there is some example. Let's look at this example. A traffic light weighing 100 Newton hangs from a vertical cable. Vertical cable. Tied to two other cables. Two other cables that are fastened to a support. The upper cables make an angles of 37 degree and 53 degree with the horizontal. Find the tension of the three cables. So here you can see the cables, table 1 and table 2 and table 3. And they give you the angles between them. And if this is 53 and this is the 37, this angle is 90 degree. This is a right triangle. So find the tension in the each of the three table. So you must to find what is the T1, what is the T2, and what is the T3. How can you solve it? First of all, you must to conceptualize the traffic light. You must assume cable and nothing is moving. So this is a stable and in equilibrium. Then categorize as an equilibrium problem. So acceleration is 0, so that F net is equal to 0. So all the components must be equal to 0. Fx is equal to 0 and net Fy is also equal to 0. Okay, so let's start to solve it. Let's start to solve it. For solving it, I'm going to use whiteboard. Okay, it is more useful. Yes, you can see the whiteboard. We are going to use it. So the question is, you can see the question. This is example 4. And what they give you the angles and that traffic light weighting is 100 Newton. Okay. Now let's start to solve this problem. Here, what is the important? First of all, you must draw free body diagram. You must first draw the free body diagram, and free body diagram is drawn here. You can see for the traffic light there are two forces on it. What are they? First one is T3 upward and Fg, which is the gravitational force, is downward. And for the other cables, we want to separate them. There is a T1 and T2 and T3. We know that this is 90 degree. So if here is 37 degree, here is also 37 degree. Okay. So after you draw the free body diagrams, it is important to also take the components. So let's also write the components of the objects. So how can you write the components? There is a T3 downward. There is a T2x, T2y, and this side there's a T1x and T1y. Okay, did you see? Now all the forces on the same direction. So for example, T1x and T2x is on the x direction, and T1y, T2y, and T3 are on the y direction. This is a vector, but this vector has only y components. Okay, so this is also, you can write this T3y. Let's write it T3y because it has only, it has only y component. T3y. Okay. Now after you draw the free body diagram, let's look at what they give you. They give you the weight of the light, traffic light. So weight of the traffic light is given as 100 Newton. So weight of the traffic light is 100 Newton. So how can you calculate weight? Weight is mg, and gravitational force is also mg, so they are same thing. So Fg equal to weight of the traffic light, which is equal to 100 Newton. This is also equal to mg. So after that, you can write the Newton's law to solve it for the equilibrium case, because the system is equilibrium. First, let's draw for this part B. For this part, this free body diagram, F net equal to MA. Okay. And in the equilibrium, for equilibrium, F net equal to 0. So after that, you must write the forces, net forces, T3 J hat minus FG J hat equal to 0. From here, you can find that T3 is equal to FG. And what is the value of the FG? 100 Newton. So T3 is equal to 100 Newton. T3 is equal to 100 Newton as a magnitude. Okay. First of all, we found what is the value of the T3. After that, now we are going to next step to find what is the T2 and T1. For this purpose, we are going to use the free body diagram of this C. So let's use it. So what are the forces? F net equal to 0 because the system is in equilibrium. So that Fx net is equal to 0 and also Fy net is equal to 0. From the Fx is equal to 0, you can write that the forces on the x direction. What are they? T2x I hat minus T1x I hat equal to 0. So what are these forces and how can you calculate them? T1x equal to T1 cosine theta. What is the T1? T1 is, you don't know. So T1, theta is 37. So T1, let's calculate the cosine. Cosine 37 is equal to 0.8. So 0.8 T1. And what is the T2x? T2 times cosine theta. T2 times cosine 53. So it is equal to cosine 53 is 0.6 T2. Okay, after you found these components, you can put it here. T2x is 0.6 T2 I add minus 0.8 T1 I hat equals 0. So from here, what can you find? You can find the value of T2. T2 is equal to 0.8 T1 over 0.6. So T equal to 0.8 over 0.6 is 1.33 T1. You find a relation between the T2 and T1. So there are two unknowns. To find the unknown quantities, you need another equation. And another equation is coming from Fy net. So Fy
Excuse me,
net
sir, I have a question.
equal to 0. Okay, this is for x direction. For x direction.
Okay, please ask.
And this is for y direction.
Yes, please ask your question.
Direction. Okay, so what are the forces on the y-axis? Ty, T2y, j hat plus T1y j hat minus T3y j hat equal to 0. So what are these quantities? So let's look at here. Let's calculate them. T2 or T1 y equal to T1 sine 37 and T2y equal to T2 sine 53. So by using the calculator, you can find it. This is 0.06 T1 and this is 0.8 T2. After that, use them inside this equation. T2y is 0.8 T2. Okay, plus y is 0.6 T1 minus, what is it, T3y? T3y is T3y is equal to 100 Newton because T3 has only one component and 100 Newton equals 0. So here also there are two unknowns. What are they? There are two unknowns. So what are they? T2 and T1. So how can you find it? You must use this quantity and plug in to this equation. Okay, take this one and put it here. Okay, so after that, what you are going to find? 0.8 times T2. What is the T2? 1.33 T1 plus 0.6 T1 minus 100 equals 0. So from here, 0.8 times 1.33 is equal to 1.064 T1 plus 0.6 T1 minus 100 equals 0 plus 0.6 1.664 T1 equal to 100. So T1 is equal to 100 over 1.664. So 100 over 1.664 is equal to 60.1 Newton. So this is the magnitude of the T1. So how can you find T2? Now it is very easy to find T2. Okay, this is the answer for T1. You can also find what is the T2. T2 is equal to 1.33 times 60.1. So T2 becomes 79.93 Newton. So this will be T2. Yes, we solved the problem by first drawing the body diagram. After that, we use Newton's first law and equilibrium condition, which is the F net is equal to 0. Separate them in the components and we solve it. Yes, have you got any question? Did you understand?
Doctor, can I ask a question, please?
Yes, please write in the meeting chat.
Okay, yes, any question?
Doctor, for each system, I mean for the traffic light and the other, the tension is in different direction, right? Like
yes, you must look at the coordinate system. So for example, minus x-axis is negative, positive x-axis is positive.
but T3 of the first system is not equal to the T3 of the second system, or the same? Same but different direction.
Yes, you must to consider them separately. So each
Uh,
system must be considered separately.
they have same magnitude or no?
As a magnitude, they can be same, but as a
Yes.
direction, it can be different.
Okay, okay. Thank you, doctor.
Okay, you're welcome.
Excuse me, sir.
Yes,
Is there
please ask.
is there a mistake in the free body diagram between C and B? Because according to C, the direction of T3 is downwards, and according to B, the direction of T3 is upwards.
You mean look at the part B. You mean the part B? In the part B, F3 J hat minus FG J hat is equal to 0. If you look at the part B, if you look at the part C, what you can see, you must take the component of the T1 and T2, okay, because there are two components. And firstly, I consider the x component. I write that x direction. For the x direction, T2x minus T1x. And for the y direction, T2y, because it's up, T1y is also up, minus T3y. This is fine.
I was asking in the free body diagram.
Okay, yes, I can see
So
it.
the one with the traffic lights shows that
Okay.
T3 is upwards, as you can see.
Yes, positive.
And the one
Yes.
that's on the Cartesian plane, the one that has been represented on the Cartesian plane, says that T3 is going downwards. So which one is it? Because they're both T3, but they're going in different directions.
Yes. As I said before, you must do them separately. Okay, you must divide the figure in separate parts. For example, what I wrote here, T3y, T3j hat minus FGj hat is equal to 0. This is for the traffic light. Okay, this equation is for traffic light. After that, I found what is the T3 now, 100 Newton. Okay, and then I look at the other figure. Okay.
Okay.
So you must do them separately.
Okay, thank you.
You're welcome.
Yes, it's clear.
Okay, well done. Let's continue. Okay, let's look at the other example.
Sir, I have a question.
Yes.
Sir, can you please explain a free body diagram once again?
No, you must draw yourself. We are going to ask you to draw. Okay, so we solve this problem and find the answers. After that, another case is the accelerating objects. So this is different than the equilibrium, and here you must use Newton's second law and its component. First of all, again, you must draw the free body diagram, and then apply the Newton's second law, and then separate them in components and solve the problem. Okay, there is another example. So let's look at this sample problem. Okay. Okay, so what is the problem? The problem, they ask to find here this is the problem. Here you can see it. Let's also take the figure, and this is the free body diagram which is given to you. This is very important. Okay, so in this program, what they ask to find here, it is very simple example. They said that a man weighed himself with a scale in elevator. So the man is inside the elevator and weighed himself while the elevator is at rest. He measures a weight of 800 Newton. So its weight of the man is weight of the man is equal to 800 Newton. Okay, so what it means, the weight? Weight is calculated by mg. Okay, so by using this weight, you can calculate the mass. First, let's calculate what is the mass of the man. So mass of the man is equal to weight m over g. So 800 Newton over 9.8 meter per second square. So if you divide it, you can find that it is equal to what? It is equal to 81.6 kilogram. Okay, this is the mass of the man. Okay, now we can start to the problem. Part A, they ask you find what weight does the scale rate if the elevator accelerates upward. So what happens if the accelerator is accelerating upward? So upward means A is acceleration is equal to plus 2 meter per second square j hat. Okay, it means that it is moving upward, as you see in the figure. In the figure, you can see it. Here, you can see easily. If the elevator is going upward, what are the forces? You can draw the body diagram. There are two forces. One of them is F normal upward, and another one is gravitational force downward. And the acceleration of the elevator is up. So how can you write the Newton's equation? So first of all, F net is not equal to 0, but it is equal to ma. So what are the forces? One of them is normal force. I show by F normal J hat minus mg J hat equal to m a J hat because it is going upward. After that, your aim is to calculate weight. So for the elevator, to find the weight, you must know the normal force. So it is related with the normal force. F normal is equal to mg plus ma. So F normal is equal to mg plus a. So when you put the values inside, m is 81.6. G is 9.8 and A is 2. From here, you can easily find the weight of the new weight of the man when the accelerator is going upward. 9,629. 9,629 Newton. This is the new weight of the man when the elevator is going upward. So what happens? You can see that easily. 962.9 is Newton is larger than normal weight at rest. Why? Because the elevator is going upward, so it gains some weight. So if you are moving on the elevator to upward, your weight is increasing. And part B, that time, now at part B, what weight does the scale read if the elevator accelerates downward? So if the accelerator is going downward, what happens? Acceleration is minus 2 meter per second squared j. So what will be the weight of the man? So how can you calculate it? How can you calculate it? Again, we are going to use F net equal to ma. So what are the forces? You can see forces are same, only the direction of acceleration is changing. So F normal J hat minus mg J hat equal to minus m a J hat, because this time acceleration is going downward. This is very important. So F normal becomes mg minus ma. So F normal is mg minus a. When you put the values, 81.6, G is 9.8, A is 2, minus 2. Okay. So from here, F normal becomes 636.5 Newton. And here you can see that this is smaller than 800 Newton. So when the elevator is going downward, your weight is decreasing. Okay. So if you want to find your weight less than the before, you must go to the elevator and go down. Okay. So this is also one simple example. Have you got any question?
Doctor, I have a question, please.
Okay. So let's
Doctor.
continue with the next example.
Okay, what is the question?
He in the question he was asking for weight. Why when we get the normal, I mean the Fn, it is not equal to weight. Like it is not the weight, real weight.
Okay, when you are standing on the ground, your weight is equal to mg. Okay, but if you are in the
Yes.
accelerating frame, like an elevator, your weight is changing. Okay, because
Yeah,
your normal is not equal to mg, because there's a ma.
but it is still mg, not f.
No, but in the definition of the weight, your weight is equal to mg when you are at rest. Okay,
Ah, okay. Uh,
it is
one more
definition
thing.
for at rest.
Uh, yes, it is only at equilibrium when Fn and weight like equal each other, right?
Yes, at rest it is equal to each other.
Yes, only at
But
rest.
if but yes, but if the forces with angle, this time also normal is changing. So there are some example, you will see it.
But if the person was moving at x-axis, weight and f of Fn will be equal each other too.
So if you are walking on the x-axis, equal to again mg, because there is no motion on the
Ah, okay.
y-axis.
Okay, okay. Thank you, doctor.
You're welcome.
Okay, so let's continue with the next example. Okay, so we found the answers correctly. Let's go to the next example. In this example, this is different because here, as it can be seen from the figure below, a constant force possessing magnitude of F is upward, exerted upon a box of mass 10 kg, which is placed on a vertical surface. This force makes an angle of 37 degrees with the horizontal. Draw a free body diagram for the box. Determine the F if the box doesn't move. Determine the force if the box accelerates upward with an acceleration of a 1 meter per second square. Determine the F if the box accelerates downward with an acceleration of a 2 meter per second square. Okay, so let's look at this example. Okay, so how can you solve it? How can you solve it? First of all, let's put up, not this one. Let's take the question. Okay, this is the example 6. Okay, example 6. So how can you solve this example? First of all, you must draw free body diagram as said in the part A. Okay, let's draw the free body diagram. There are some important points in the program. What are they? First of all, a box of mass, and they give you this important point, a box of mass 10 kg, frictionless. This is the angle. Okay, these quantities are given to you. And you don't know f, which we are going to find. First, free body diagram. For these objects, free body diagram is drawn like that. There is a, this is mass of the object m. There is a gravitational force downward, which is equal to Fg. There is also normal force, but here the object is touching to the wall. Okay, this is the touching surface. So the normal force is always perpendicular to the surface. So this is the F normal. After that, there is also external force, which is this F. And the external force F is in this direction. Okay, this is the external force F. Of course, there are components of the F. Let's draw the components. There are two components of F. One of them is this Fy. Another one is this Fx. And if this is the 37 degree, so if this is the 37 degree, this one is also 37 degree. After you draw the free body diagram, now you can solve the part B. In the part B, what they said, find F if it is not moving. So if the acceleration is 0. So if acceleration is 0, F net is equal to 0. So how can you solve it? First, you must write first you must write and components. So what are the components? X components and Y components. So the forces on the x-axis and forces on the y-axis. Which one is useful to use it? You must think about it, because here there are two unknowns. You don't know F, and also you don't know F normal. So there are two unknowns. You don't know this and you don't know this. But in the question, they ask you to find F. Okay, so if you use the x direction, there are two unknowns, Fx and F normal. Okay, but if you use y-axis, y direction, there is only one unknown, so you can solve it. So I'm going to only use now y direction. So for y direction, Fy net equals 0. So what are the forces on the y direction? Fy j hat minus Fg. What is the Fg? Fg is, we know that Fg is equal to mg. mg j hat. Okay, because Fg is equal mg as a magnitude equal to 0. So from here you can find that Fy equal to mg. What is the Fy? It is equal to mg. So Fy is equal to m is given 10 times 9.8. It is equal to 98 Newton as a magnitude. But you find F, not Fy. So F is a vector, has a two component, Fx and Fy. So you know Fy. How can you find F? It is very simple, because Fy equal to F sine theta. Okay, you must use this relation, and F is, you don't know, sine 37 is equal to 98, because here you know it. So from here you can find what is the F. So F is equal to 98 over sine 37. If you divide it, you can find that it is equal to 163 Newton. So this is the answer for the part B. So we found what is the force F if the object is not moved. And in the part B, part C, this time they said that if the box accelerates upward. So if the box is accelerating upward, what happens? Acceleration is equal to positive 1 meter per second squared J hat. And F net this time is not equal to 0, but it is equal to ma. Now, by using the Newton's second law, we can solve to find what is the F. So how can you solve it? And how can you find it? Again, you must use the free body diagram, which we draw it already. Then you must write all the forces. What are they? Now also I'm going to use firstly y direction, Fy net equal to 0. So what is the Fy net? Fy minus, this is J hat, Fy J hat minus Fg J hat equal to, but this is not equal to 0, sorry. This is not equal to 0. This is equal to what? M A Y. Okay. Because there is an acceleration. And here, this is also important. The acceleration is upward. So this is Y. So AY is 1. Okay. So it has only Y component. M A Y J. Okay. So then let's write it. F is equal to Fg is mg. Okay, so take the other side. So Fg plus may, which is equal to mg plus may. So then Fy is equal to, put the values, m is 10 times 9.8 plus 10 times ay. Ay is 1. So at the end it's equal to 108. So if Fy is 108, what is the F? Similar to this one, F sine 37 is equal to 108. So F will be equal to 108 over sine 37. So it will be equal to 180 Newton. So this will be the force if the object is accelerating upward. Okay, and part D is also similar, but this time the object is going down. So what is changing? Acceleration must be -2 because it is going downward. Okay, this is homework. Please try to do yourself. Any question? Any
Yes.
question?
Should we send you the homework?
No need to send it.
Oh, just for me. Okay.
Okay,
Thank you.
let's continue. Yes, we saw the example 6. Now let's look at the another important problems, which are the inclined planes. So we categorize as a particle under net force since it accelerates. Force acting the object, the normal force acts always perpendicular to the plane, and the gravitational force is acts always straight down. So for example here, if the object is on the inclined plane with some angle theta, this time the normal force is opposite to the surface. If this is the surface, normal force is like that. Okay, and the gravitational force is directly straight down, so like that. So here you can see that they are not on the same line. So first choose the coordinate system with x along the incline and y perpendicular to the incline. So we choose the we rotate the coordinate system. So we choose this direction is x and this direction is y, but Fg is between them. So you must replace the force of gravity with its component and then apply the model of particle under the net direction and the particle in the equilibrium to the y direction. So how can you take the component of Fg? There are two components, one this and the other one is this. Fg is equal to mg. So how can you put them? If this is theta, okay, here is 90 degree. Here is 90 degree. Here is 90 minus theta, and here is theta. So if this is theta, it becomes mg cosine theta, and this one becomes mg sine theta. So after that, you can use the component of the force of gravity and solve the problems. So, and if there is a friction in the inclined plane, so and the block is sliding down the plane, so friction act up to the plane. So it means that because we know that the friction force is always opposite direction to the motion. So if the object is going down, the friction force is applied to the upward direction. And this setup can be used to experimentally also determine the coefficient of friction, because mu s, which is the static friction coefficient, is equal to tangent theta. And now we are going to derive it. And also in the experiments in the laboratory, you are going to do it later. And mu s is, we use the mu s if the object is at stop, at rest. Use the angle where the block just slips. And mu k is kinetic friction coefficient. We use it where the block slides down at a constant speed. Okay, let's look at this example and solve it. In this example, this is the inclined plane. Suppose a block with mass 2.50 kilogram is resting on a ramp. If the coefficient of static friction between the block and ramp is 0.350, what maximum angle can the ramp make with the horizontal before the block starts to slip down? Okay, let's look at this problem and try to solve it. Here, let's look at this problem and try to solve it. Let's go to the whiteboard. Okay, very good. This is the inclined plane question. And then also take the figure, because our figure is also important. Take the figure and put it here. Okay, now let's look at the example and try to solve it. So how can you solve this example? How can you solve this example? The free body diagram is drawn, but you must draw yourself in the question, in the exam. and when you are solving the problems. First of all, let's analyze the free body diagram for inclined plane. There is normal force opposite to the surface. There is a gravitational force straight down, and you must take components of this gravitational force. There are two components, this one, mg cosine theta and mg sine theta. And there is a friction force opposite to the motion direction. It tends to this slide down, so the friction force is opposite direction. So how can you solve this problem? To solve this example, first of all, you must write what they give you. They give you mass of the object. They give you coefficient of static friction, and they ask you maximum angle. So they give you mass of the object is 3.50 kilogram. They give you mu s is 0.350, and they ask you theta max. So how can you find it? And they said that before the blocks start to slip down, so it means that acceleration is equal to 0. So how can you solve it? Okay, so F net is equal to 0. This is a vector. So there are components. So what are the components? X component. So F X net. Let's write F X net equals 0. And another one is Fy net equals 0. And another thing is Fy net equals 0. So first, which one you are going to use? First, you must use Fy net, because you don't know what is normal force, and first you must find normal force from the Fy net, and then you must use it to calculate friction force. Okay, so let's use this one. What are the forces on the y direction? F normal j hat minus mg cosine theta j hat equal to 0. So F normal will be equal to mg cosine theta, which is equal to m is 2.50 times 9.8 times cosine theta. But you don't know what is the theta, you are going to find it. So 2.50 times 9.8 is equal to F normal will be equal to 24.5 cosine theta. This is the F normal. Why F normal is important? Because friction force Fs is equal to F normal times mu s. Now you can calculate what is the friction force, because Fs is equal to 25.5 cosine theta times mu s. Mu s is 0.350. So Fs will be equal to 8.58 cosine theta. This is important because we are going to use it later. Then let's go to the Fx net. What is the Fx net? What are the forces on the x direction? Don't forget that for the inclined plane, this direction is x and this direction is y, because we rotate the coordinate system. So what are the forces? We take this direction positive, this direction negative. Mg sine theta I hat minus F friction I hat equal to 0. So what is the Fs? We already found it. And M is 2.550 times 9.8 sine theta minus 8.58 cosine theta equals 0. From here, what can you find? You can find that, let's calculate 2.50 times 9.8, 24.5 sine theta equal to, take this to other side, cosine theta. So sine theta over cosine theta, divide to the cosine theta, equal to 8.58 over 25.5. So this is very known things. It is equal to tangent theta. Okay, this is equal to tangent theta, and tangent theta is equal to 28.58 or 24.5, 0.35. And you know how to calculate the theta by using the inverse of tangent. So theta will be equal to inverse of tangent 0.35. So by using the calculator, you can find it. It is equal to 19.3 degree. So this will be the maximum angle for block. Yes. Any question? Any question? Any question? Okay.
What's the chapter?
Very
Is
good.
this?
So let's continue.
Sorry.
Any question?
Yes.
Yes.
What's the chapter?
This is chapter 5, Newton's law.
So this chapter is included in our exam, right?
Yes.
Tomorrow.
This is your quiz will be on this chapter only, Newton's law.
Okay.
Okay, very good. So let's continue. Okay, after solving this example, let's continue with the next one. Yes, we found correctly. Another important thing is the multiple objects. If there are more than one objects and they are connected with this rope or string or cord, what happens? Again, you must draw a free body diagram, and then if there is a one cord, so the one cord, it means that both objects are connected with the same rope. So the tension is the same for both objects. And it is important that acceleration is also same for both objects. So but as a magnitude, direction can be changed. If you look at here, they connected with the same rope. So the acceleration for M1 is upward direction. However, acceleration for M2 is downward. Okay, but as a magnitude, they are same. For example, 10 meter per second square, 10 meter per second square, but the directions are different. And for the friction questions, which I mentioned before, always you must remember that friction force is opposite to the motion, and it's parallel to the surface in contact. And then you must use the Newton's law, draw the free body diagram, and solve the questions. Friction acts only on the objects in contact with another surface. First, draw the free body diagram, apply to Newton's law, and then solve it. For example, for here, what are the free body diagram and how can you draw it for the multiple objects? For M1, first of all, you must separate the objects and you must draw the free body diagram separately. For M1, what is the free body diagram? Tension upward and gravitational force downward. And acceleration is upward. And for the second object, gravitational force downward, normal force upward, there is an external force F, which the direction of theta, and you must take the components of this force, X component and Y component, and also there is a tension to the left side, and there is a friction force, kinetic friction force opposite to the motion, and it is on the direction of the left. Okay. After you draw the free body diagram, you can solve the problem. Okay, now let's look at this problem. Okay, in this example, they didn't give you any values, but I am going to give you some values. But first, let's go to the solve it. Let's go to the whiteboard and solve it. Okay. Okay, this is the problem. Please, okay, please turn off your microphone. Please turn off your microphone. Okay. Let's look at this problem. In this problem, a block of mass M1 is equal to 15 kilogram, and a ball of mass M2 is 8 kilogram are connected by a massless spring over a massless pulley as shown in the figure below. The coefficient of kinetic friction between the block and the table is mu k 0.2, and a force of magnitude F is 150 Newton. Is applied at the angle of 15 degrees as shown in the figure. First, draw the free body diagram for M1 and M2, then calculate the acceleration of two masses and tension in this spring. Okay. I'm going to put it here. Okay, first, let's write what they give you. In this question, what they give you the M1, 15 kilogram. This is, you can find in my lecture note, this is problem 5. Okay, problem 5. And M2 is also given 8 kilogram. And also they give you the kinetic friction coefficient 0.2, and also they give you the magnitude of the force 150 Newton with angle theta, and theta is 50 degrees. Now, how can you solve it? First of all, you must draw free body diagram. The free body diagram of this system, you must consider them separately. First, free body diagram for M1. For M1, the free body diagram is like that. There is a tension. There is a normal force upward, F normal. There is gravitational force downward. There is a F with angle theta. There is a friction force opposite to the motion, Fk. And there is also tension on the rope on the left. Okay. After you draw the free body diagram, yes, you must take also component of F. There are two components. One of them is this Fx, and the other one is this one, Fy. Then you must draw free body diagram for M2, and for M2 it is very simple because there is tension upward and M2G downward. But let's write it also Fg. So if you write Fg, you must write this is Fg1 and this is Fg2. Okay, to understand. But T's are same because they connected with the same rope. But magnitudes are same, directions are different. And you must also show the direction of the acceleration. For this one, acceleration is upward, but for the M1, acceleration is right. After you draw the free body diagrams, now we can solve the problem. So how can you solve it? To solve this problem, you must write Newton's equations. What are they? Yes, you must be careful and then write the Newton's equations. So here I can show you. So we draw free body diagram. You can see free body diagram is drawn like that. It is similar. There is a tension upward, M2G, which is the gravitation force downward. And for M1, tension on the rope left, friction force to the left, force with the theta, normal force upward, and M1G is downward. And then you must take the components. Okay, now let's continue to solve it. So how can you solve it? First, let's do for the M2. For M2, write the Newton's equation. So part B, F net is equal to M2A. Okay, for M2. First, for M2. So what are the forces? There are only two forces, Tj hat minus M2G J hat equal to M2A J hat, and A is also positive. From here, what you can find the magnitude of T. T is equal to M2G plus M2A. So T as a magnitude is equal to 8 times 9.8 plus 8 times A, but you don't know what is the A. So there are two unknowns. This is T equal to 78.4 plus 8A. So this is the first equation. There are two unknowns, A and T. So if there are two unknowns, you need two equations. This is the first equation. Another equation will come from M1. For M1, again F net equal M1A. But here there are two directions on the motion, so there are two components. But the motion is on x-axis, x direction. So for the y-axis, y direction, fy net equal to 0. Why? Because the box is not flying. It is moving on this surface. So let's write the forces on the y-axis. Let's write what are the forces? F normal j hat minus plus Fy j hat minus M1G j hat equals 0. Are they correct? Yes. F normal upward, Fy upward, Fg downward. So Fg is equal to M1G. From here, what you can find? You can find what is the Fn. Fn is equal to, take them to other side, M1G minus Fy. So what is the M1G minus, what is the Fy? How can you calculate Fy? Fy is y component. So y component is equal to F sine theta. F sine theta. Then let's put the values. F normal becomes M1 is 15 times 9.8 minus F is 150 sine 50. From here, you can find what is the value of F normal. F normal is very important when you're calculating friction force. So 32.1 Newton. This is the F normal. F normal. Okay. After that, let's go to the calculate Fx. For Fx, Fx net equal to not 0, max. Why? Because there is a motion on x-axis for m1. This is m1. Yes. So what happens? What are the forces on the x-axis? Fx I hat minus Fk I hat minus T I hat equal to m1 ax. Also, this is I hat. How can you solve it? How many unknowns? Fx is f cosine theta I hat. Fk is, how can you calculate Fk? Fk is equal to F normal times mu k. And F normal, we know, 32.1. Mu k is 0.2. So that Fk will be equal to 6.42 Newton. Okay, so you know Fk and you know them. So let's put the values. Fx is F time cosine theta. So what is this? F is 150 cosine 50 minus Fk is 6.42 minus, what is the T? You don't know it, but from here you can plug it in it. 78.4 plus, but here plus, but there is a minus. Okay, so this minus is for both of them. So it becomes minus 8a equal to m1 is 15ax. From here, only unknown is a. As a magnitude, yes, they are same. So let's write them a because they are same thing. A, so they are same as a magnitude. And now calculate what is the A. How can you calculate? By calculator, 150 times cosine 60. No, not 60, cosine 50 minus 6.42 minus 78.4. So it is equal to 1.6. equal to, take this to other side, 23a. From here, a is equal to 0.5 meter per second square as a magnitude. But here they say to calculate acceleration for two masses. Yes, this is same for all of them, but for vector quantity, for m1, a is equal to a1 is equal to, or don't say a1, a is equal to, as a vector 0.5. Look at this one. I had meter per second square, but for m2, a is equal to 0.5 j hat meter per second square. Okay, because it is going upward. After that, find what is the t. Now it is easy to calculate the tension because you know this relation. So t is equal to 78.4 plus 8a. So t is equal to, oh, there is something. T is equal to 82.4 Newton. And we found what is the T. So this is the end of this example. We find A's and also we find T. So this was also the old exam question. So you can see that you can solve it easily if you draw free body diagrams correctly and then step by step write Newton's equation in components and solve it. Have you got any question? Okay, very good. Let's continue. Let's look at the next example. Next one is yes, let's look at the next one. Next one is this one. In this example, there are two masses, M1 and M2. M1 is 2 kilogram and block of mass M2 is 1 kilogram are connected by a string of negligible mass. Block 2 is pushed by a force of magnitude 20 Newton and angle theta 35 degree. The coefficient of kinetic friction between each block and the horizontal surface is 0.2. So what is the tension in this string? So let's look at this example and try to solve it. Okay. How can you solve this example? First of all, you must draw free body diagram. This is one of the important points. Because if you don't draw the free body diagram, you cannot solve it. So let's draw the free body diagram and try to solve it. how can you draw the free body diagram? You must draw it for separately. But let's try what they give you. They give you oops. They give you the M1. So what is the value of M1? What is the M1? M1 is 2 kilogram. M2 is 1 kilogram. And what is the F? F as a magnitude is 20 Newton and theta is 35 degree. And also they give the friction coefficient. This is the kinetic friction coefficient, mu k is 0.2. And then they ask you what is dt. So how can you do it? First, let's draw the free body diagram. For M1, this is the center of mass for M1. So there is F normal 1, and there is also Fg1, and there is a tension on the rope T. And then let's look at for the for M2 free body diagram. For M2, there is a F normal 2, there is Fg2, there is tension on the rope, and also there's the external force, F. Okay, and this external force has some components. So what are they? There is a Fx, and here Fy. And where is the angle? The angle is here. If angle is theta is here, the other angle is where? Here. Okay. So another thing is, important thing is friction force, because in the question they said that there is a friction force. There is also kinetic friction. So let's draw also friction force for both of them. Fk. And for this one, it is also Fk. Okay. So after you draw the free body diagram, now you can solve the problem. So drawing the free body diagram is very important. So let's solve it. First of all, let's write the equation for M1. So there is the acceleration, and the motion of the direction is right. Okay. So motion acceleration is this direction, and for M2 is also acceleration is this direction. It's same magnitude because they connected with the same rope. So F net equal M1A. So what are the forces? But first of all, let's write it. There's a friction force. So if there's a friction force, the y direction is very important to calculate the normal force. So Fy net equal to M1. But here on the y-axis, the acceleration is 0 because the objects, both of them, are moving on the x-axis. Okay, so acceleration is only on the x-axis, x direction. On the y direction, there is no acceleration. So what are the forces? F normal 1 minus M1G equals 0. From here, F normal 1 is equal to M1G. What is the M1? 2 times 9.8, it is equal to 19.6 Newton. We find what is the F normal 1. This is very important to calculate friction force because Fk, and there are two objects, so let's put K1 and K2, okay, because they are, don't confuse them. So Fk1 is equal to F normal 1 times mu K. F normal 1 is 19.6 times mu K is 0.2. So you can find the kinetic friction force for first object. It is 3.92 Newton. Okay. After that, let's write Y direction. Fx net is equal to M1A. Why? Because it is moving on the X direction with acceleration. What are the forces? The forces are T I hat minus Fk1 I hat equal to M1A X. Okay, what is the T? You don't know. Fk1 we found, so T minus 3.92 equal to M1 is 2AX. This will be your first equation. What are the unknowns? T and AX. There are two unknowns, so you need to use two equations to solve it. Okay, so from here, what you can write that simply T is equal to 3.92 plus 2AX. Then go to the M2. For M2, F net equal to M2A. Then first Y direction, Fy net equal 0 because this one is also not flying. So what are the forces? F N2 J hat minus M2G J hat, but there's also external force F with Y component minus Fy J hat equal to 0. So from here you can find what is F normal 2 is equal to M2G plus F. What is the Fy? How can you calculate Fy? If F has two components, this one and this one, this is Fy, this is Fx. So Fx is F cosine theta and Fy is F sine theta. F sine theta. Then put inside the values and calculate F normal 2. M2 is 1 times 9.8 plus F is, what is the F? 20. 20 times sine 35. So from here you can find what is the F normal. So F normal is 21.3 Newton. After you find F normal 2, now you can calculate what is the kinetic friction force on M2. So Fk2 is equal to F normal 2 times mu K. So 31.3 times 0.3 it is equal to 4.26 Newton. So this is the friction coefficient on M2. Then let's use Y component. Fx net equal M2AX. Okay, similarly similarly to this one. So how can you write it? What are the forces on the x-axis? Fx I hat minus t I hat minus fk2 I hat equal to m2 ax I hat. Okay. So here, what is the fx? Fx is f cosinus theta. So what is the f? 20 times cosinus 35 minus, what is the t? You don't know t, but you know this equation, so you must to plug inside. So take it here, take it from here, and put it here. Okay, so 3.92 minus 2ax minus fk2 we already found 4.26 equal to, what is the m2? M2 is 1ax. Okay, now let's solve it because you have only one unknown. From here, by using calculator, 20 times cosine 35 minus 3.92 minus 4.26, we found that 8.20 equal to 3ax. And from here, ax is equal to 2.73. And then you can find also tension. 3.92 plus 2 times 2.73. So T is equal to 9.38 Newton. So this will be tension in the spring. Oops, sorry. Yes. Yes, this will be the answer. Yes, have you got any question? Have you got any question? Okay, so let's look at the last problem.
Sorry, teacher.
Yes.
Will you upload this lecture on the application or on?
Yes, I will upload. Yes, I will upload.
Okay, thank you.
Frictionless pulley as shown in the figure below. Assume the incline is a rough surface with friction and the take M1 2 kg and M2 6 kg and the angle is 60 degrees. Draw the free body diagram for the masses M1 and M2. For a given Fk 4 Newton, find the magnitude and direction of the acceleration A. And then if the length of the incline is 2 meters, how long does it take the block to reach at the bottom of the incline? Okay, so now let's solve it. Also, let's put the first you must draw free body diagram. After that, you must find acceleration A and also yes, this is the problem. Part C and part D. So how can you draw the free body diagram? How can you draw the free body diagram for this object? You must draw them separately. So what they give you as a value, you know only M1, M2, angle theta, and Fk. Okay. And you are going to find the acceleration. Free body diagram for M1. For M1, there is a tension on the rope T, and there is a gravitational force down, Fg1. And if M2 is going down, M1 is going up. So the motion and acceleration is upward. Okay. And free body diagram for M2. And this is the object. Okay. So there is a gravitational force downward, M2G. There is a normal force opposite to the surface, F normal. There is tension on the rope, T. Okay. Let's write it correctly. And because this is like that, directly downward, M2G. And there is a friction force opposite to the motion, because the motion is this direction. So Fk for 2, and M2G has two components. M2G cosine theta, and this one, no, I'm wrongly. Let's change the color. This one and this one, because object is going down. And theta, this is, if you draw it correctly, you can see that this is theta. Okay, so this will be mg cosine theta, and this is mg sine theta. And the direction of the here is x, and here is y. And if you look at this inclined plane, you will see that mg sine theta is always on the x direction, and this is on the y direction. There is a mg cosine theta, because this is the theta. If you draw it here, you will see better. This is the mg, m2g. This is 90 degree. Here is 90 minus theta. Okay. So if you draw these two components of the m2g, and this is 90 degrees, so this is theta. Okay, so that this is m2g cosine theta, but opposite it is m2g sine theta. Okay, here I show it better. After you draw the free body diagrams, now you can solve the problem. First, let's look at the M1. F net equal M1A. What are the forces? Tg j hat minus m1 j hat equal to m1 a j hat. So from here, what you can find that t is equal to m1g plus m1a. So what is the t? T is equal to m1 is 2 times 9.8 plus 2a. So you find the relation between t and a. So t is equal to 19.6 plus 2a. Because here there are two unknowns, a and t. After that, you must go to the second object. If you look at the second object, f net equal to m2a. Again, you must divide it in the components. First, let's look at the y direction. Fy net equal to 0 because the object is moving on the x direction. Okay, this is the x direction. This is the y direction. Oh, okay. So that what are the forces on the y direction? F normal j hat minus mg cosine theta j hat equals 0. So from here you can write that F normal equal to mg cosine theta. So F normal is equal to, this is which m2. What is the m2? 6. So 6 times 9.8 cosine 60. From here you find F normal. So F normal is equal to 6 times 9.8 times cosine 60. 29.4 Newton. Why it is important? Because it is important to find Fk. So Fk2 is equal to F normal times mu k. What is F normal? 29.4 times. But here, I forget that they give you Fk, okay? So if they give you the Fk, you don't need to calculate F normal. Yes, this is a good point because it makes the problem easier. Okay, so they give you. So if they give you, you don't need to F normal to find it. So because Fk is already given for Newton. But we found it, it doesn't matter. So let's go directly. What is the F x net equal to m a x? What is the force on the x direction? T. One of them is T. T I hat plus Fk2 I hat minus m2g sine theta. This is all these twos are 2, okay? m2g sine theta I hat equal to what? m2 ax I hat. But it is going down. So if it is going down, the acceleration is negative. So that, what is the t? You must use this t. Use this t inside here. So put inside 19.6 plus 2a plus fk2 is 4 minus m2 is 6 times 9.8 sine 60 equal to minus m2 is 6ax. Now you have one unknown. Okay, this a and ax are same because they have same magnitude. So let's write them a equal to ax as a magnitude. Okay. So now we can calculate it. So it is 27.3. equal to, take to other side, 8ax. So ax is equal to 3.42 meter per second square. But here, yes, they ask you acceleration, and so this is the acceleration as a magnitude. So magnitude, you can show by like that if you want, 3.42 meter per second square. But for direction, this is different for two objects. For M1, A is equal to 3.42 J hat meter per second square, but for M2, A is minus 3.42 I hat direction. Okay, this is the end of this problem. But here also there is another important thing. What it is? Another important thing is to calculate what? To calculate part C. Part C is find if the length of the incline is 2 meter. This is 2 meter. L is 2 meter. How long does it take the blow to reach the bottom of the incline? Yes. Here, this question is a motion, related to motion. So we connect the Newton's law with motion. So how can you solve it? This is the x direction, and you know the acceleration, so you can calculate. Because x is equal to initial position, you can take it 0, reference point. There is no initial velocity, so 1 over 2 a t square. From here, you know the x, which is equal to length. You know the acceleration. You can find what is the time. Okay, you can find it. This is a simple homework for you. So today we solve many problems. I hope that they are useful for you. But in the home, we are at the chapter 5. We are at the chapter 5 now. In the home, please repeat these problems and try to solve them again yourself. And 1 minute, I show you.
Doctor, can I ask a question?
Okay, here, maybe you didn't see it, but you can see the answer. And this is the chapter 5. Try to
Okay. Yes. If you have a question, please ask.
And when he was when you were sketching the FBD for M2, it was written that down is mg sine theta. Why?
Because for the inclined plane, always you must take down the M1 G sine theta. Okay.
But yeah, but in the sketch, yes, but in the sketch it was written sine, not cosine.
Because there are x and y part. And for the inclined plane, different than the other questions, what we take the x. If let's find this question and show you. 1 minute. I close it first. Let's open it again.
fk to f1 and so equal to 3 over 2 a t squared. It's chapter 5 now.
Okay, let's run. Can you see now? It isn't open.
I can't see the screen.
Yeah.
Okay, no problem. Yes, here the sketch on the left.
Yes, which one? For M1 or M2?
For M2.
Okay, for M2, if you look at if you look at the free body diagram,
Yeah.
okay, differently, what we said that F normal is always what directly opposite to the touching surface. Okay, this direction, and we choose the x-axis like that. And we said that one side is positive and the other side is negative. And if theta is this one, if this is the theta, okay, if this one is the theta, the upper side is 9t minus theta. So the other side, right side, become theta. So if you look at this theta, the closest one is cosine and opposite is sine theta. So always for the inclined plane, you must consider like that. Okay.
And if the theta was the opposite one, the
So
one beside.
if they give you the opposite one, that's time. You can take that 90 minus theta, or you can use cosine theta. Oppositely, like that.
Okay. For each theta we use opposite cosine or sine.
Yes.
Okay. Thank you, doctor.
Yeah, you're welcome. And another important thing is tomorrow you will have a quiz on the Newton's law. So please study hard to this chapter. And also I have uploaded a video for the it is writing that video lecture 5C, and it is the video lecture for the solution of the more problems. So you will find, you can watch it. It is I think 30 minutes or something. You can watch it. There are more solutions of the programs, and I think it is enough for you for the midterm exam and also the quiz. So good luck to you. Okay, so please study hard. So see you next week.